All right, so right now we're going to talk about how to name and write formulas for covalent compounds. Now, we've been doing this for ionic compounds, but now we're going to switch gears a little bit and look at how to do this for covalently bonded molecules. So the first thing you have to know when you're getting ready to name something or write the formula for something is which set of rules to follow. Do you follow the ionic rules or do you follow the covalent rules? Some of the rules are different, some are the same, but you still need to know which set of rules to follow. So you've got to identify if a compound's ionic or covalent. Ionic has the word ion in the name. It means you have to have oppositely charged ions. You have to have a metal that gives up electrons and becomes positive, and you have to have a nonmetal that takes those electrons and becomes negative and makes an anion. If you don't have both, then you don't have an ionic compound. When you name ionic compounds, you do it just like we've been practicing. You state the name of the metal. So in this case, it's magnesium. State the name of the metal. If it is one of those elements that makes more than one charge, then you might have to stick a Roman numeral in there. But this is just magnesium. Then you figure out what the nonmetal is, and you change the ending to ide, I-D-E at the end. So oxygen becomes oxide. That's it. Magnesium oxide. Look at the next one. Magnesium's hooking up with 2 chlorines. It doesn't matter. It's still magnesium. Chlorine gets changed to chloride. If you didn't know the formula MgCl2, you could figure it out from the name magnesium chloride, because you would look on a periodic table and you would say magnesium makes +2, chlorine always makes -1. You would crisscross them and you would get MgCl2. The name is enough, and a periodic table obviously, but the name is enough to tell you what the formula is going to be. The last one, this one looks crazy, we got a lot going on here, but it's still magnesium is our metal. It's given up electrons to this little group here. Phosphorus having a party with oxygens, hanging out with oxygens. This is a polyatomic ion. We call it phosphate. These are all ionic. They all have a metal giving up electrons to a nonmetal, a cation, positively charged ion, and a negatively charged ion. And those two are attracted to each other, and that's what an ionic bond is. No prefixes. This is unbelievably important. Don't change what you've been doing when you deal with ionic compounds. No prefixes. And when you want to figure out the ratio, just crisscross the charges. Covalent compounds. These guys have all nonmetals. That's why it's all pink here. There's no metals giving anybody electrons. The little carbon only has 4 valence electrons. It needs 4 more. Oxygen only has 6 valence electrons. Each oxygen atom needs 2 more to get to 8. They all need electrons. There's no metal to give them the electrons that they need. So they're going to make a covalent bond. They're going to share electrons and cooperate, and everybody's going to get an octet. So how do we name these guys? Well, we have to use prefixes. And the reason we have to use prefixes is that these guys can bond in many, many, many different ways, in many different ratios, with the same elements. So we need prefixes to tell us what they're going to do. The ionic compounds, we know what they're going to do. As soon as you know the charges, you crisscross them, you know what the formula is going to be. Covalent could be creative. Carbon wants to bond with oxygen. Well, maybe it does so on a 1:2 ratio. Maybe it does so on a 1:1 ratio. Who knows? We need prefixes to tell us what they're going to do. So take a look at how we name this, and I bet you know what this first compound is. Carbon dioxide. We stick a prefix in there. That di tells us there's 2 oxygens. We didn't do that over here, magnesium chloride. You don't use prefixes with ionics. The reason we need prefixes is because carbon can hook up with 2 or carbon can hook up with 1 oxygen. So we use monoxide. The prefix mono means 1. Carbon can hook up with 6 chlorines. Well, we want to indicate that there's 2 carbons and 6 chlorines all hanging out together, sharing electrons so everybody's happy. We need prefixes to tell us how many there are. So covalent is going to include prefixes. So what are those prefixes? Well, I bet you know a bunch of these already. 1 is mono. 2, di. 3, tri. 4, if you think about the game Tetris, every little shape made of 4 squares. Think tetra, 4. Penta, you probably know the pentagon. Hexa, hexa means 6, hexagon. Hepta is 7. Maybe this one's a little unfamiliar to you. You probably heard it before, but maybe you didn't use it that often. But you should know hepta is 7. Octa, like an octopus, that means 8. Nona for 9. And decade, or deca, like decade, for 10. So I bet you a lot of these you already know. But in case you forget, they're also found on your periodic table. If you look in the front top portion, it's right here, covalent prefixes. So if you do forget what they are, you can always look there. All right, we're going to need those prefixes only when naming covalent compounds. So how do you name a covalent compound? You add a prefix to the name of the first element, except if there's just one. Don't write mono for the first element. There's always going to be 2 in the examples that we work with. The first of the 2 elements, if there's only one of them, don't write mono and don't say mono. You don't, like if I said, what's this? You would say it's carbon dioxide. You wouldn't say it's monocarbon dioxide. Number 2, add a prefix to the name of the second element. And you still, this is something in common with ionic, you still change the ending of the second element only to "ide." Only the second element. Now, number 3 is one of those things that you're just going to have to get comfortable with. Things are going to eventually start sounding correct to you or incorrect to you. So if I said carbon monoxide, you would say that sounds a little funny because those 2 O's right next to one another are duplicates. We're going to drop any of those O's or A's if they're 2 vowels right next to one another. So it would be carbon monoxide. Let's look at a couple examples here. This is the epitome of why we need prefixes when dealing with covalent. Look at every single example here. What 2 elements are bonded together in every single one of these 6 examples? N and O. We don't look up charges. They're both nonmetals. Not one of them is trying to give up electrons. The other one's trying to take the electrons. They're all pooling their electrons together and sharing them. So they can be really creative when they do this, and they can hook up in all different ratios. So we need prefixes to tell us which ratio it is. So this first one, simplest of all, a nitrogen and an oxygen atom bonded together. Now, if I was naming this, I would not put mono here. I would leave this blank. I would just say nitrogen. And then the second word, I always change the ending to "ide." But I got to stick on a prefix, regardless if it's just one. In this case, there's only one, so I write monoxide. The next one, I've got nitrogen, there's 2 of them, and 1 oxygen. So I want to indicate that there's 2 nitrogens. So I look at my prefix. What's the prefix for 2? Di. So I write dinitrogen. That's all one word, dinitrogen. And then there's only 1 oxygen. So just like before, I write monoxide. Dinitrogen monoxide. The next one, same numbers, just flip-flopped. Now I have 1 nitrogen, so I don't write anything. But the second element, there's 2 of them, so I use the prefix di. Nitrogen dioxide. Now, if I didn't give you this, if I just gave you the name, if you don't see a prefix in the beginning, you know there's 1 of them. And if you see a prefix, you know there's going to be 2 of this. Oxide is really oxygen, and there's 2 of them. That's what the prefix told me. Look at the next one. We got 3 nitrogens. Trinitrogen. Don't change the ending. 7 is hept. Now notice hepta. We don't want an A and then an O right next to one another, so it's heptoxide. You know what? If you spell this slightly incorrectly and you put both vowels there, it's not a big deal. You'll eventually get the hang of it. The next one, we got 2 nitrogens, 3 oxygens. Think about what it is. Type it in. If you decided it's dinitrogen trioxide, you are right. Think about the last one. Give it a shot. There's 5 nitrogens, so it's pentanitrogen. 10 is deca. We got that A going on there, so we're going to drop it. Dec oxide. Pentanitrogen decoxide. All right. When we write formulas, this is unbelievably easy as long as you know your prefixes, because the prefix tells you what there are. There's none of that. Figure out the charge and crisscross. The prefix tells you how many. Triphosphorus. Tri means 3. Pentabromide. Penta means 5. So, triphosphorus. Put a 3 after the phosphorus, because there's 3 of them. Pentabromide. Penta means 5. Put a 5 after the bromine, because there's 5 of them. Penta means 5. Carbon. I don't see a prefix. That means 1. So, we normally don't write ones. I'm just going to put it here so you understand that there's only one of them. I didn't skip it. Tetra. What's tetra? Just like the game, 4 little squares make up each shape. 4. Tetrafluoride means there's 4 of these. So it's CF4. Dicarbon. Di is 2. That tells me there's 2 carbons. Octahydride. Octa means 8. Put an 8 there. All right, so covalent compounds, if you know your prefixes, are unbelievably easy. What we're going to do in a minute now is start to mix everything up. We're going to mix up ionic and covalent, and you're going to have to follow different sets of rules. You should have a periodic table out so you can look quickly at these prefixes, or if it's ionic, figure out what the charges are.